Let's start with the cornea, the clear front line, where light first bends, so images shine. It works.
This is the setup for the experiment. So we have here the eye model, and it includes usually the retina screen, the aperture, and different lenses. Some of them are concave and convex. It depends on if it's a positive focal length or negative. You can see this one, it's positive 307 millimeter, and some of them are negative. Those are negative 1000. Negative 1000 millimeter. And some of them are cylindrical, and the cylindrical ones are the ones that has these two edges. This one basically has these two slots. It means it's a cylindrical lens. And we have adjustable focal length lens. Okay, this one. Eye model stand, ruler, protractor, and a light source with an object, a bucket filled with water. I would say between 1 to 2 liters of water, clean water. Then we have the optics pinch. So now we are going to demonstrate how a converging lens corrects far-sightedness, which basically called hypermetropia, by focusing images that would otherwise form behind the retina to be on the retina itself. So first we need to create a model, like I would say a perfect normal eye vision model. Then we will start from there. So we have here the eye model filled with water. You have the retina screen on normal slot, and we will place the 62 plus 62 millimeter lens, this one. I hope you can see this one, into the septum slot itself. Then we will light up the light source on the 4-1. Then we will adjust the distance so that we have a clear image. And basically this is usually it's going to be a difference or a distance of around 35 centimeters. We have done this before in a different video, a different lab. So now we have a good image. You can see it here. The zoom in. I hope you can see the 4 number. It's focused. So let's simulate the hypermetropia case by moving this retina screen at the far slot. So we see that we don't have a good image. Then let's try to put the pupil in the slot A, and see whether we have a good image or not. It is more clear, but still it's not good. Let's turn off the light. So you see that closing your eyes, it makes it a bit clear, but it's still not clear. Let's see whether we can see a far or a distant image or not. So we will be moving the eye model to see the far image or the window as we used to do. So let's go and see. So we see the image here. You can see the image. It seems to be clear. Let's remove the pupil. So still I see a clear image, a focused image of the window itself. So you can see that when we have this problem, that the retina screen is in the far slot, or a person who has a problem of hypermetropia, they still see the distant images, but they don't see the near images, despite even closing their pupil. So now, let's correct this problem by eyeglasses and using converging lens. Okay, we will use converging lens to correct this problem. We will try different ones. So I am going to basically try this 120 lens. Not sure whether you see the number or not, but this is a 120 lens. We will put it in slot 1 in front of the eye model as if it is a an eyeglasses. So we don't see anything. Let's change this one. Let's have this one. It is a 1000. Sorry, it's a 400 millimeter plus 400. So let's see. So now we see a much better image, a focused image here of the number 4. It's a much better image. Let's try to change the lens itself to another one. So this one was 400. Let's try a bigger one. Let's try the 1000, see whether it is better or not. So put it in slot 1 inside the front of the image. Let's see. So the signal is bad, or the image is bad. So I think the 400 plus 400 millimeter converging lens was the best option to correct the problem of the hypermetropia. And we put an eyeglasses to correct this, or basically, for example, if we remove this one, basically the crystalline line starts to adjust itself, or the focal length, so that it has a system that gives the correct image on the retina screen. So for example, let's simulate this one. If we added this lens on front of the septum at the slot B, so you see here that while doing this, we kind of adjust it to have a more focused image. I know it does not look. Let's try to make it more focused so that you can see it. Maybe we need to go closer to the image itself. So let's get closer so that you see better. Like for some reason I'm not able to focus it, but the image here is better when we have these two lenses, the system of 62 and the 120. If we remove this one, let's see how focused. See the signal or the image itself. When we put this one in like the slot B, you have a much better image. Okay, sorry, I see it in focus more than what it looks on the camera itself. So this is the experiment of simulating the hypermetropia and correcting this issue in the eye model. I hope you have found this lab beneficial for you. So if you like it, please like and subscribe and share it with your friends. And wait for me for my next video. Thank you.
With the lens lens just right behind to focus all sights that the eye can find. Oh, the eye